Welcome back to Second Collisions and the main auditorium track, which is focusing on artificial intelligence, machine learning, and deep learning. The medical track is taking place in parallel in the Globe Auditorium. To moderate the first session, it gives me great pleasure to introduce you to my colleague, Marcus Nordberg, who's the Head of Resources Development of the Development and Innovation Unit at CERN. Marcus, the floor is yours.
Thank you, Rachel, and good afternoon, everybody. It's a real pleasure and a thrill to be here today. And I'd like to introduce Michael Feindt. He's our next speaker. Michael has worked in particle physics at DESY, CERN, Fermilab and KEK since a long time ago, in fact. And 1997, he has been, as of, a professor at KIT. But his work on neural networks started already earlier in 1993, as he was applying it to the data coming from the experiments at that time. And that led him to create and invent the NeuroBayes algorithm for predicting conditional probability densities. And that, in turn, led him to set up the company Blue Yonder, that he will share more exciting stories about just in a moment. So again, Michael, welcome, and I'd like to hand over the floor to you.
Yeah, thank you very much, and thank you for the invitation and for the introduction. Yeah, so my name is Michael Feindt. As Marcus already said, you more or less gave the talk already. I am a physicist by education, and I started my physics career at DESY in Hamburg, then went to CERN. That was in 1983. Then I went to CERN, later became professor at KIT and made experiments there in Fermilab and KEK. On the right side of the screen of the slide here, you see the experiments I have worked with: Pluto, Cello, Delphi, CMS, CDF, CDF2, Bell, and Bell2. So I'm still doing it at the moment. I'm really focusing on the company, and you will understand this later. But since just a few years ago, I still had a large group, especially in the Bell experiment in the recent years, and we were very successful there. And I show you also something about that. So my machine learning history actually began in 1993 when I trained my first neural network at CERN. In 2000, later I invented the NeuroBayes algorithm, which was a neural network for the output is a probability density, not only one value, one number, but a complete distribution. And this, I found out, was extremely interesting for applications also outside of physics. And that led me then in 2002 to actually try the first applications outside physics. And I founded my first company called Feindt. Then in 2008, I founded Blue Yonder, what we now call the original Blue Yonder. Later, 10 years later, Blue Yonder was acquired by the much larger software company JDA Software, and I will tell about, details about that later. 2 years later, JDA was then renamed to Blue Yonder because Blue Yonder, which was a smaller part of the large company, was actually the more up-to-date, more future-oriented and value-producing part of the company, so that the whole company renamed itself. And just now, in 2021, actually the complete Blue Yonder was acquired by Panasonic, and at an valuation of $8.5 billion. So huge value. On the top of the slide, I show three things which were important for artificial intelligence. One in 1997 was that the chess world champion was a computer program, IBM Deep Blue, that we would today not really call artificial intelligence, but it was something where really something very difficult for humans was really being made better by a machine. So what we did, we also automated the work of particle physicists, so of ourselves, because we had lots of experience. And for example, for reconstructing exclusive BDKs in more than 1,000 channels, we wrote a program then which made it with about 72 neural networks inside, which made all the hard decisions. And we found then that on a 10 years data set of the Bell experiment, this program was 2 times more efficient at the same purity as the 400 physicists of the collaboration in 10 years, including myself, together before. And a few years later, in 2017, there was a second go of the same idea, but just even more efficient. And so this made the reconstruction efficiency 4 times as efficient as we were able to do as humans before. And when you know that just the operation of the Bell experiment for 10 years the costs were 0.7 billion, so 700 million euros about, then to let's say, be able to efficiently double the luminosity or even quadruple the efficiency, corresponds billion euro in the first round and 2.1 billion in the second round. So it's a huge value. 2017 was also the year when AI became popular, so very popular, because the world championship in the game of Go was won by DeepMind, by a deep neural network in that year. So we started very early and were also very successful, quite parallels to DeepMind and so on, but also very different approaches that we had. So this was one of the things I did at the very beginning and when I was a CERN fellow in 1991, 1992. There the Delphi drift calorimeter was a very nice thing in principle, but the energy and spatial resolutions were catastrophic. And that was the first time I tried to solve this by software, simply by looking at data and into detail, because this had 144 modules, the calorimeter, and we found that every of the modules had different problems, but by looking really at data, we could solve lots of them. And that was a very large success. And really for me, I learned that with software, with looking at data, you can really understand lots of things much better than if you only think theoretically what could go wrong. Then, as I said, we started to use neural networks in 1993. They were not very successful and not very popular at that time. But then we found we could do lots of nice things. For example, bee flavor tagging. We had a neural network and it was much better in performance than the normal methods, rule-based methods. We did on the right hand, you see particle identification in Delphi with DDX measurements and liquid and gas ring emitting Cherenkov counters, combining all the stuff, then we were again much better. Then the NeuroBayes neural networks was something very decisive for my whole life. First, it was an algorithm based on a neural network architecture, which could, for real valued quantities, not only give a mean value or predicted value, what comes out as a function of lots of input variables, but the whole distribution. You see it here on the right, lower plot, also on the right, in the upper left plot of the lower quadrant, that is a CDF, and the PDF of the output distribution, individual distribution, could be learned by this neural network. Later, I found that this has huge value for economy. So we gained lots of experience with neural networks in Delphi. And over 10 years, we were extremely successful in inclusive B reconstruction, energy, directions, Q values, flavor, tagging, and so on. B plus 0, BS lambda, B separation, and so on and so on. I don't want to go into details. And we also were in the press in the first time at the time when for the with the that was later the year with the CDF experiment, or CDF2, we discovered or really made clear that BS mesons oscillate, and we could measure the frequency of that. And that was also due to lots of other neural networks that were helping there. Okay, I talked about this already. This was the Bell experiment, in the thing that more than I think it's the second edition, more than 3,000 different decay channels, an automatic reconstruction of one of the beam mesons. There's always two beam mesons to the same event, and then you can, you know exactly what belongs to the one, and then you can do enormous good studies of the other beam meson, and you know the flavor of that at production time. Very important for time dependency, p-violation studies, and so on. And then we also did things really together with other institute at KIT, so that we put this neural network into an FPGA chip, so that good decisions could be done on trigger level or even on readout level of the experiment. And we had a world record there at that time of 8 billion intelligence decisions per second with one chip. So that's the physics part, but then I had the idea to do something completely different, but with the knowledge that we gained at CERN, and as I go outside the ivory tower of physics and think now that we have a measure where we can do nice predictions with a neural network, including all the uncertainties. That was very new. So we had also predictions of individual uncertainties. What I had done privately was a bad thing. I lost money at the equity market here at that time, but we had just moved to Germany back and wanted to build a house. And in this time here, where it was rising, we planned it a little bit larger than everything. We lost about 20%. That was not good. And that was a time where I thought to myself, the whole day you are doing nothing but statistical analysis and complex predictions, but only for physics. But if it were for my own money, I trusted a bank advisor. And I said, never again. So I downloaded Yahoo Financial Data at that time, used NeuroBayes for predicting equity price changes, and saw that on short-term scales and small amounts can be predicted. So on paper, we saw some predictability, and we had first contact through also a car insurance. So again, something very different. Basically, we had access to accident databases, and we could really also predict quite a lot there. And that then was the idea. Okay, we will found a company, and this so with just two students. So that had the luck that they were just there at the right time at the right place, but they were also good, of course. I founded then the first company, Physics Information Technologies, Feindt. And so we did then also some predictions. For example, this was for Germany's largest drugstore chain, DM. And what you see here is the prediction of turnover of every of their more than 1,000 stores at every given day. And you see really here error bars 1 and 2 sigma intervals. And in red, you see then what was the truth, but we didn't know the truth before. Of course, this was predicted from historical data. And so this worked extremely well. And we did do lots of things and won lots of competitions in different areas. Then some financial companies became interested in that, and we actually built a low-risk, market-neutral fund for institutional investors, the Lupus Alpha NeuroBayes short-term trading fund, which ran over 6 years and made very good money. Also there we were in the press quite often. And then we made a test for Otto, Germany's largest distance retailer, and competitor to Amazon in Europe and especially in Germany. And we saw that we could make much better predictions as they did for how many of every single item they sell in the next short term or also the next half year and so on. Then someday my telephone rang, and it was actually the boss of the CEO of Otto, and he wanted to buy my company. I said, okay, no, I don't want that, but we can found a 50-50 joint venture that was then called Feindt Products and Services. That then we started in this company professionalization. So up to then we were only physicists, so data scientists, mostly physicists or mathematicians, IT guys. But then we also introduced sales, marketing, PR, finance, engineering, IT infrastructure, product development, HR, a growth plan, and so on, and built a real company. 2011, then we renamed this company from the clumsy name IT Products and Services to Blue Yonder. Blue Yonder stands for Behind the Blue Horizon. It is this what normal people on Earth cannot see, but a pilot on a plane can see. So, and this should somehow tell us that this company can see look further into the future than others. Now we decided, so we had lots of projects at the time, also for industry, for insurance, for different things, for retail. But then we then we had a big investment of private equity in 2014, and we decided to really concentrate on products, build products that can be used for many clients. For example, demand forecast with probability distributions for retailers, replenishment, also using an individual cost pricing for retailers, causal program with individual customer targeting for retailers. And so we concentrated on large customers and repeatable things and internationalization. We changed from Fortran and C++ to Python then. We changed our own data center that we had to the public cloud. Now we are one of the best partners of Microsoft Azure and do everything there. And from what was at that time called an unpopular renting model, so that the software was not as bought but only rented, we changed nothing but the name, because this is what we had before already was software as a service, so that we also ran it and operated everything. And today this is cool. Then in 2018, Blue Yonder was acquired by JDA. So we had, for some years, we had lots of companies that wanted to buy us. But this was the first time where we thought it makes sense. JDA was a competitor of ours from America, 40 times as large as we were, but they were more classical software, but for the complete supply chain, and they they were really good and very well underway in the whole world. But they did not have really machine learning, data drivenness, and software as a service. They were just going into that direction. So this made much sense to come together there. The idea was very clever, so started in '85, and then acquired the world best demand management companies and the world best planning and transportation management companies and the world best warehouse and labor management companies, and then Blue Yonder. And so this led to one integrated set of end-to-end solutions for the whole chain. And the vision of JD at the time was, as a moonshot vision, the autonomous supply chain. So first have visibility over the complete supply chain and everything from manufacturing to via transportation and so on up to the retailer. Then a predictive application inside, and prescriptive and autonomous, finally autonomous. And that is what we were building together with them and what we have now. So you see, from suppliers, fabrication, transportation, distribution centers, distribution to stores and online stores to final customers. And we have lots of stuff there, demand prediction, store orders, supplier orders, truckload building, and so on. And everything is automated. And we have built one AI-powered supply chain platform for doing all this. Now came the day that I'm very proud of. In 2020, what we started as JDA there ended as Blue Yonder. So the whole company rebranded itself into Blue Yonder, because what small 2.5% of the company was putting in was the future. Now the new Blue Yonder has about 3,300 global customers, 5,500 professionals working for it, and annual revenue larger than $1 billion, 450 plus patents granted and pending, 75 of the top 100 retailers of the world use Blue Yonder. 7% of the top 100 consumer packaged good companies of the world use Blue Yonder. We have about 25% EBITDA, strong cash reserves, about 150 customers per year, and we are the only company in the world that is named a leader in all four Gartner Magic Quadrants. Gartner is a software evaluation company that always compares the software companies in different areas, and in every single supply chain, Blue Yonder is in the top quadrants. Yeah. We made, and this is also, I'm proud of this, we now do about more than 10 billion automated AI decisions per month for our clients, and it's growing fast. So real AI also has to scale. That is not only the algorithm, it's a complete development behind it for scaling. That's very important. And we have delivered more than 1 trillion predictions already to our customers in total. I'm also proud that we serve profitability, not only profitability, but also sustainability. So you can steer the strategy of what the companies want. Is it only profit, or is it a mixture of, for example, also sustainability and avoiding food waste? And that is absolutely possible. So I'm almost at the end now. Just this year, I said it already at the beginning, we were acquired by Panasonic. So the first you think, why Panasonic? They are a hardware company. Yes, they evaluated Blue Yonder to $8.5 billion. We're also very proud of that. Brand and company will stay and grow, but we put together, Panasonic built lots of sensors and edge devices, IoT devices, and for putting in data from the edge into the software of Blue Yonder and building appliances. That is what our future wants. So I'm almost done. This year is just some things: understandable, interpretable AI, economic AI, sustainability in AI. These are stuff we have already productized. We are working on fair, discrimination-free AI, on causality, reinforcement learning, and long term, it may be that we will have applications for quantum computing. That is not yet clear. So, but this is also really very exciting things. And what I have learned, this is also an important message. Not only particle physics is interesting and demanding, also in the rest of the world, they're extremely fascinating tasks, and you can have really influence. We really have influence now in the world, because lots of the largest retailers of the world use our artificial intelligence. The first ideas of that were really coming from when I was working for CERN. Thank you very much for your attention.
Thank you very much, Michael, for sharing this fantastic journey. And I understand from my colleagues that the participants have the possibility of asking questions through the chat link. So I'm looking at the shared document from Lisette. I don't see any questions there so far. But while waiting to see, Michael, if there are questions, let me ask a little bit elaborating on the early part of your work. So could you share with us this transformation from a hardcore statistics, high energy physics guy into something that is kind of, let's say, call it more useful for society, at least seen by our family?
Yes. Yes, so that was quite some transition. So the first thing I had to learn was that I have to give talks without any formulas. And also with graphics must be very simple, words must be simple. So one has to communicate on a very different scale, but of course without losing the trust. And I think it was, for us, it was very important that we have really these two things. So we have this hardcore scientist in the company, but of course we also must have, so you're not allowed to be too modest. You must do PR. You must communicate. You have to go out. You have to work with the press. You have to go to conferences again and again. Many of these things are also important for a career in academia. Right? Also there, if it's only you who knows that you're doing great things, it doesn't it's not enough. You have to go out. You have to tell it to people. You have to make it public. You have to build trust. So I think this is important. But then you also have to learn that money is not a bad thing. Right? Because only if you have money, you can do things. You can create jobs. I was, for example, extremely proud when I always saw on the Christmas parties that we had 200 people, most of them actually good scientists, were sitting there, and some. Then I thought, okay, of course we did great work. We worked as in CERN, so in teams, not alone. But of course, as I also knew, okay, it was my idea that now gives good money and permanent position to all these very clever guys. This is something. This is really a great feeling. So yeah, I think it's a bad thing that often academia and economics are so separated. Right? I think they should be much closer together and work closer together. And very often, I think it is. Yeah. So scientists are also sometimes only interested in their bubble and nothing else. Right, and in academia, in the economy, it's often that the powerful people are most of the time not good scientists, but good speakers and good managers. Also, brings things together in order to have an influence on the world.
Okay, so we have a question. Michael, did you patent NeuroBayes? Did you patent anything else?
Actually, at the beginning, not, because then we also thought it was not yet possible at that time. So what we did there is that let's say, kept it secret. But it was we always had a running version for CERN and for physics that was for free, but not with the source code. And, that was not public. We did not. Yeah, at the beginning we did not patent it, but so since when we were larger, we actually started to patent algorithms. For example, the main algorithm that we are using now is called cyclic boosting, that we patented, but we also then published it. But we also don't give the source free, because of course in the economy it's lots of things are also stolen directly. So we have quite some companies that try to copy one-to-one what we were doing. I had this in physics also already, but in economy, of course, it's even more dangerous. So yes, the new algorithms, we have some new algorithms patented, but the original ones were actually not patented.
Okay, so we have a couple of more minutes here. So I'd like to, we had a chat beforehand, so I'm privileged to know a little bit more than what you said. I understood from our chat that, Michael, you are your baby has grown up, it's very successful, you're clearly a proud father, you should be, we all are. I understood that you are kind of looking back to your professorship at Karlsruhe. So could you maybe share what your next baby might look like?
Yeah, I don't know it exactly, I must say. So, of course, I still have an important role to play in Blue Yonder, and now with the Panasonic. It's also interesting and new things again, where I think where one of the options is clearly to stay there. But that there are other things which are very interesting. So of course, I also know some small young companies. So it might be that I also already do some coaching and so on for new small companies, also smaller investments that I do there. That is of course something which is also interesting. But for sure, at least I want to give also lectures, maybe not beginning physics lecture, but how to really scale AI things to students, and also about entrepreneurship. So this idea, so what are the errors that you should avoid and so on. That I think is also very interesting, and I like to share this, my experience there. And of course, a university is always a good thing.
Well, thank you very much, Michael. It was really a pleasure to see you here today, and thank you for sharing these exciting developments. And I hope that we will be able to follow your new whatever you are going to be working on. And I think
Yeah.
we have about 2 minutes left. So if you still want to share something, please go ahead.
Okay. Yeah, I think that two things. So first, what is really interesting is that for physicists, for clever, analytically thinking people, there are lots of interesting things around, and so one should, take the chances and do that. We are also growing and are also looking for people for especially I'm always looking for physicists since I know that they are so great and have the right mindset in order to really build something new and exciting. So that's that's an important message. Then I think also for the physics community, we see and also with the whole development in AI, we see how important knowledge is there. And so I'm also in my public speeches and when I talk to the press, I'm always saying we need more people in this area. We need more people studying mathematics, information sciences, natural sciences, these things. It should be more popular. And I think when I see how it is in Europe, also in North America, then I see how much effort in India, and they are much, there's more willingness to do the hard studies, the hard topics, and this is something that I would like to also make advertisements in Germany and in Europe and in North America too, because I think there are so many things to be done, and it's so interesting, fascinating, and we need more intelligence and more work there.
Okay, thank you. So your mobile phone might be ringing a lot, Michael. So thanks once again. I'd like to thank you all for joining.
One last word. One last word. On LinkedIn, simply with my name, Michael Feindt. So please follow me there. From time to time, also I post something very technical, which might be interesting.
Yes, we saw that actually your LinkedIn page there. So please, everybody, go and chat with Michael. And thank you again for joining. And back to Rachel and other colleagues in the studio. Thank you.
Bye. Thanks.